Okay, now today I am going to discuss about ABCD parameters. That is ABCD parameters. We can call these ABCD parameters as trans parameters, transmission line parameters, ABCD parameters or transmission line parameters, or we can call these as chain parameters as well. Chain parameters. Okay, why we are calling this one as a transmission line parameters in the sense we to use these parameter in the analysis of power transmission line. So we are calling it as a transmission line parameters. Then why chain parameters in the sense whenever two or more networks are connected in a cascaded parameters or a chain parameters. Okay, we are going to use these ABCD parameters in analysis of that type of cascaded networks. Okay, this is a ABCD parameters, transmission parameters, chain parameters. Okay, now simply how the transmission parameters are derived. Now, this is one transmission line having sending end 1 dash, receiving end 2 dash. Okay, this is sending end, this is receiving end. Okay, this is the transmission line. Here I am going to mark sending end voltage as ES, receiving end voltage as ER, plus minus, plus minus. Sending end current as IS, receiving end current as IR. And this line that is L. This is my line. Okay. Now I'm going to represent this one in a two-port network. Okay. This is my two-port network. Two-port network. We know for two-port networks, there are input port as well as output port. 1 dash, 2 dash. But in two-port networks, I1 is flowing into the network, I2 is also flowing into the network. Okay, now plus minus V1 plus minus V2. Okay, now this is input port, this is output port. Okay, now these parameters are used in the analysis of a power transmission networks. Okay, this is a sending end port. Here we are representing as the input port. Receiving end port we are representing the output port. Okay, but we can observe here IR and I2. This is going out. IR here is going out. I2 is coming into the network. So while writing the equations, we are writing minus I2. Okay, now voltage V1 and V2, the voltage V1 and V2, that input port voltage and currents, we are going to represent in the output port voltage and current, that is V2 and I2. Thus, I can write like this. Okay, V1 is equal to function of V2, comma, minus I2. Why minus I2? This IR, see here, the direction of IR and I2 are different. Okay, so V2 and minus I2. Then coming to I1, function of V2 minus I2. These are two equations, functions, where input V1 and I1 are dependent variable. These are dependent variables. dependent variables, and V2 I2, these V2 and I2 are independent variables. Now what I'm going to do, I'm going to express this function in terms of relations, V1 in terms of V2 I2, I1 in terms of V2 I2 with ABCD parameters. Simply I'm going to write V1 is equals to A V2 plus B into minus I2. Then coming to I1 equals to CV2 plus D into minus I2. Okay, these two equations I can write in the matrix form as here V1 I1, okay, A B C D V2 into minus I2. I am going to express these equations in the matrix form V1 I1 A B C D V2 and minus I2. Okay, now these A B C D are nothing but the transmission line parameters. Now I need to find these in means A B C D. I need to find those. How? Just see here. Just remember, otherwise I will write this equation again, no problem. Here. Now we know that we have this V1 equals to A V2 plus B into minus I2. Then I1 equals to C V2 plus D into minus I2. Okay, first case, let I2 minus I2 equal to 0. If I'm going to put minus I2 in above equations, I'll get V1 equal to AV2. That is A equal to V1 by V2 when minus I2 equal to 0. Next case, I1 equals to CV2. C equal to I1 by V2 when minus I2 equal to 0. Then coming to second case, okay, second case, V2 equal to 0. Okay, what we are doing is, in the sense, whatever the independent variables are there, V2 and I2, we are making them as a 0, then writing the equations. V2 equal to 0, second case. Okay, V2 0 in the sense, V1 equal to minus B I2. Okay, B equal to minus V1 by I2 when V2 equal to 0. Then same in the second equation, this equation I1 equals to minus I2D, that is D equal to minus I1 by I2 when V2 equal to 0. Okay, now see here, we have achieved, we have calculated for A, B, C, D. Here this A is reverse voltage gain. See, otherwise I'll write A equal to B equal to C equal to D equal to. Okay, this A is V1 by V2, B is minus V1 by I2, C is I1 by V2, D is minus I1 by I2. When this is V2 equal to 0, this is I2 equal to 0. Okay, now this A is called as open circuit reverse voltage gain, open circuit reverse voltage gain. Okay, this B is called as circuit short reverse transfer impedance. Okay, here V1 by V2. Okay, no unit, V1 by I2, that is here I1 by V2. that is admittance. I1 by I2, no unit. Okay. So similarly, if C equals to open circuit reverse transfer admittance. Okay. And similarly, this one short circuit reverse current gain. Okay, we have calculated A, B, C, D. Now, condition for symmetry. A equals to D. A equals to D. Condition for symmetry. Condition for symmetry. Then AD minus BC equals to 1. That is condition for reciprocity. Now we'll solve this first one. We'll take the simple problem. Dependent sources. Is nothing but I am expressing the ABCD parameters in an equivalent circuit. Okay. Now yeah, this one plus minus V1, this is plus minus V2. Okay, this is given as 2 ohm, this is given as 3V2 plus minus, this is 5I1. Okay, here 5 ohm, this is I2, here I1. Here by solving the network with the ABCD parameters or for ABCD parameters, we are applying KVL at the input side, KCL at the output side. Just remember this one. Okay, now consider network with the branch currents and the branch voltages. Where first apply the KVL at input side. If I'm going to apply the KVL plus minus, only this one only. Now here, see, apply KVL at input side. Okay, apply minus 2I1 plus to minus 3V2 minus to plus V1 equals to 0. Okay, if I'm going to apply a KVL at the input side, I got this. Fine. Now V1 equals to 3V2 plus 2I1. I'm going to call this equation as 1. Now I'm going to apply a KCL at output side. KCL, apply KCL at output side. Apply KCL at output side. See here, I2 is equals to 5I1. Then this is coming here and is going to divide into two parts, 5I1 and this current. I'm going to call this current as IA. Okay, 5I1 plus IA. Now 5I1 plus this current IA will be calculated as the voltage divided by the resistance of that branch. V equal to IR, I equal to V by R. Simple. Okay, here IA, the voltage across this 5 ohm resistor is V2. So I simply write V2 by 5. That is I2 equal to 5I1 plus V2 by I. Okay, now 5I1 equals to minus 1 by 25 V2 plus 1 by I2. If I am going to arrange, if I am to arrange above equation in terms of I1, I'll get I1 equal to minus 1 by 25 V2 plus 1 by 5 I2. I'll call this equation as 2. Equation 2. Okay, now I'm going to put this I1 in this first equation. Involve equation 2 in equation 1. Okay, if put I1 in equation 1, I'll get V1 equals to 73 by 25 V2 plus minus 2 by 5 minus I2. Okay, equation 3. Similarly, if I'm going to arrange this 2, okay, I'll get I1 is equals to minus 1 by 25 V2 plus, see here, plus minus 1 by 5, then minus I2. Here minus minus plus, simply what I'm getting, indicating then I in terms of minus I2, so that I can compare these with my basic equations. Okay, after the equation 3 and 4 with my basic equations. What are that basic equation? V1 and I1, that is A V2 plus B minus I2, then C V2 plus D minus I2. Okay, I am going to compare 3 and 4 with these two equations. I'll get A equal to 73 by 25, B equal to minus 2 by 5, okay, C equal to minus 1 by 25, D equal to minus 1 by 5. Okay, now we'll solve one more example where the ABCD parameters, okay, uh, okay, here find the transmission or general parameters for the circuit shown. See, one more term at ABCD parameter, transmission line parameters, chain parameters, as well as general parameters. Okay, see, this is the network given. Okay, given as this one is V1, this one is V2, B, B dash, A dash. Okay, here current I1, here current I2. 1 ohm, 2 ohm, 5 ohm. Okay, input port A dash, output port B dash. Input current I1, output current I2. Okay, now by definition of the transmission line parameters, we can write V1 equals to A V2 plus B minus I2. Then I1 equals to C V2 plus D minus I2. These are the basic transmission parameter equations. Now let I2 equals to 0. See case 1, minus I2 is equals to 0. What will happen if I'm going to put I2? I'll get, yes, I2 equal to 0. What will happen? Where V2 equals to 5I1. If I2 is 0, where I2 is 0, then V2 equals to 5 I1. First KVL for this loop. Okay, then we are going to calculate. 1 minute. This one I will remove. First of all, I'm going to write KVL for input side. Where plus minus. Okay. Now minus 1 I1. Okay, then minus 5 I1. Then plus V1 equals to 0, because I2 minus I2 will be 0. This I2 is 0. So minus I1 minus 5 I1 plus this V1 plus minus minus to plus V1 equals to 0. So I'll get 6 I1 equal to V1. Okay. Now if this is the case for I2 equals to 0. Okay. Now if I2 equal to 0, what will happen? V2 equals to 5 I1. Here I1 is coming. V2 equal to 5 I1, where I1 equal to V2 by 5, where minus I2 equal to 0. This is nothing but my C. C equals to 1 by 5 mho. Transfer admittance. Okay. Now V2 equal to V2 by 5. Now I am going to substitute this I1 in this equation. See here, I'm going to substitute I1 equals to V2 by 5 in this equation. 6 into V2 by 5 equals to V1. So that I will get A. Okay. Where 6 by 5 is equals to V1 by, this is nothing but A. I2 equals to 0. Okay. Now, next case, V2 equal to 0. V2 is 0 in the sense, this is 0. So, short circuit the port 2. Here, if so, V2 equals 0, then what will happen? This will short circuit, output port will be short circuit because V2 is 0. Okay, here plus minus V1 A dash B dash, this is short circuited because V2 equals to 0. Current I2 is flowing here. Okay, now this is given as 1 ohm, this and this one is given as 5 ohm. Both here coming I1 plus I2. Fine. Now apply current divider rule. Here in this case we need to calculate the D. If I am going to apply current divider rule to find this I2 is equals to, this I2 is in opposite direction of I1. So minus I1 opposite resistance 5, divided by total resistance 2 plus 5. Okay, I'll get I2 equal to minus I1 divided 5 by 7. That, see here, that is D equals to I1 minus of I2 when V2 equal to 0, that is 5 by 7. Now applying KVL at inputs, I already told whenever we are applying, we are calculating the ABCD parameters, we are going to calculate or we are going to apply the KVL at the input port, KCL at the output port. Okay, but case 1 minus I2 equal to 0, we calculated A and C. Okay, then for second case V2 equal to 0, we calculated D equal to 5 by 7. Now, if I am going to apply KVL at the input port, I am going to get B. Fine. Apply KVL at inputs. Okay, see here minus I1 minus 5 I1 plus I2, this one minus 5 I1 plus I2 plus V1, this is plus V1 equals to 0. Okay, finally what I am going to get, minus 17 by 5 I2 is equals to V1. That is nothing but, what is the formula for B? Where B is nothing but V1 by minus I2, where I can simply write V1 by minus I2 is equals to B, that is nothing but 17 by 5. Okay, now I calculated B, T, A, B. Final step is that I need to write A, B, C, D parameters. Okay, where my A, B, C, D are, okay, that is 6 by 5, then 17 by 5, then 1 by 5, then 7 by 5. Okay, these are my ABCD parameters. Similar problem will come, but just go through the videos, then you will get to know how to solve with, means where we have to apply the KVL, where you have to apply the KCL. Okay, we have discussed Z parameters, we have discussed Y parameters, we have discussed hybrid parameters, then today we have discussed transmission parameters, that is ABCD parameters. Okay,